This video provides you solutions to two numerical problems on electric potential. In both of them, potential is found at a given distance due to point charge with respect to some reference point. Let us take the first problem here. So copy the problem, move down. So this is the problem number 1. Let us see what is given. We have to find the potential V at a distance of RA, 5 meter. That means we have to find VA at a distance RA, and also another distance is given RB, that is 15 meters. So we have to find the corresponding potential also. We have to find VA and VB at distances RA and RB due to a point charge Q, which is 500 picocoulomb, and it is located at origin. So this is the data available here. And first we have to find the potential at RA, assuming 0 as potential at infinity. This is a direct calculation, it's not a problem. And also obtain the potential difference between the points A and B. Found very simple. Let us see. We have the charge located at origin. We shall find the potential at two different distances. The coordinates of the points are not given. Distance is given directly. One is RA, another one is RB. We will be finding the corresponding potentials VA and VB in this case. So VA to be found first, then VB, then we shall find the potential difference between them. Potential at A is given by Q by 4 pi epsilon naught RA. No reference is specifically mentioned. The reference point is given with respect to infinity. So we can directly go for calculation. As we all know, 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. That is for free space. 9 into 10 power 9. The charge is 500 picocoulombs. Pico is 10 power minus 12. RA. RA is 5 meters. Here 5 goes with 500 as 100. This is going to be 900 10 raised to minus 3. So that's going to be 0.9 volts. So VA is the potential at point A, otherwise at a distance RA with respect to 0 potential at infinity. Same way, VB can also be found using the similar formula. 9 into 10 raised to 9. Q is 500 picocoulombs. RB, I guess 15. So to simplify further, that is a 5 3s 500, 3 with 3. This is going to be 0.3 volts. So we have found VA and VP with respect to 0 infinity, that is zero potential at infinity. Let us look into the problem. Find the potentials at a distance RA and RB due to the point charge. So it's found. Find the potential at RA, assuming zero potential at infinity. Yeah, VA itself is the answer for this one. Obtain the potential difference between them. So no other reference point is mentioned here. So the potential difference VAB is given by the difference of both of them. So one is 0.9 volts, another one is 0.3. So it's going to be 0.6. This is the solution for the numerical one, where direct distances were given from the point charge. So in the second numerical, we have one more problem which sounds similar. Here also the point charge is given 1.6 nanocoulomb. This is also located at origin, that is 0, 0, 0 in free space. Free space means the permittivity becomes absolute permittivity, and the distance is r, 0.7 meter. So one reference is 0 to infinity, another reference is given a point at a distance of 0.5. Let us jump into first part of the problem. 0 reference at infinity means it's a direct calculation of potential at R. So V equal to Q by 4 pi epsilon naught R. This is 9 into 10 raised to 9. The charge is 1.6 nano coulombs divided by R is 0.7 meters. So all the values are there. So you can calculate this, and the answer may be 20.57 volts. So this is the potential at a distance r, 0.7 meters, with respect to 0 reference at infinity. In the case number 2, same charge, same distance, the reference will change here. So we shall find the potential at the given distance using this relation, where C will decide the change in potential with respect to reference point, new reference point given. And from the case number 1, we have the answer of 20.7 volts plus C. If the reference was not there, C would have been 0. Because of the new reference point, C comes into picture. To find C, we make use of potential at reference point V2, which is given by again 4 pi epsilon naught. The new distance R plus C. So we shall denote this as R1. So V2 is the reference potential. Let us see what is the reference potential in the problem. The reference potential is also 0 because it is given as 0 reference. 0 reference here means potential is 0, but at a distance of 0.5 meters. So what does it mean? That means the point charge is 1.6 nanocoulomb at origin. We have to find the potential 1 here at a distance of 0.7 meters. But the reference point is mentioned in the second case as 0.5 meters, V2, and V2 is given as 0. So assuming the reference potential is 0 at this point at a distance of 0.5 meter, we have to find V1 with respect to V2, with respect to the point at which potential is V2. So now, from this, V2 becomes 0, 9 into 10 power 9, 1.6 nano divided by R2 is, I think it is 0.5 meters plus C. So after calculating, we get C value as minus 28.8. So C is ready. The C can be used here to find the potential at A or potential at first point. So V1 is 20.57 plus C, 20.57 minus 28.8 is equal to minus 8.23 volts. So as the reference potential changes, the potential at a given point also changes. So this is the solution for both the problems.